When you're designing a study, it's pretty important that you choose the right sample size so that you get a confidence interval that actually has a chance at capturing the true mean or true proportion that you're examining. So in this video, we're going to look at how to achieve a certain margin of error by picking a certain sample size. So take a moment and read question 1 to yourself and then set up the equation for margin of error. All right, now I shouldn't have said equation, I should have said inequality, because what they're looking at here is a margin of error that has to be 5% max. So they want a margin of error that is less than or equal to 0.05. So if we use the formula we learned in the last video, margin of error is z star square root p hat times 1 minus p hat over n. We need all of that to be less than or equal to 0.05. Now, in this scenario, the administrators have an idea of what p used to be. The last time they did this study, they got a p hat of 0.87. So what we're going to do is we're going to set all of this up, and we're going to use 0.87 as p hat because that's like the best estimate that we have. We haven't done the study yet, so we don't know what p hat is. We're just going to use this estimate. Of course, we'll use 1.645 for z star. We can use inverse norm to figure that out. We don't know what n is. That's the point of this problem, is to estimate what our n should be. So that's the setup. At this point, this stops being a statistics problem, and welcome to Algebra 1. We are going to divide both sides by 1.645. And then to get rid of the square root, we need to square both sides. Now we have the n in the bottom of the fraction, so I'm going to multiply both sides of this inequality by n. You'll notice I also just did 0.87 times 0.13 in my calculator because I was tired of rewriting it over and over. And now to get n by itself, I'm going to divide by this whole mess, which I just wrote as number because I was getting tired of writing that. So in my calculator, I do 0.05 divided by 1.645, enter, squared, enter, and then I did 0.1131 divided by answer. That got me 122.42. So our sample has to be larger than that. Now, I'm not going to ask 0.42 of a student for an answer to this question, so I'm just going to round up and say that we need at least 123 students. So the statistics part of the problem is in orange, the algebra part of the problem is in pink. You probably don't need to write out every algebra step. I was just showing you kind of the thought process. Show some of your work on a test. You don't have to show as much work as I did. Now in this next scenario, it's a little bit different because we don't have a prior study to go off of. Suppose we want to estimate the true proportion of students who have tattoos. There's no prior study like in number 1. In number 1, we had an estimate of what p hat could be. In this example, we have nothing. So we're going to start off the same way. Z star square root p hat 1 minus p hat over n. That has to be less than or equal to 0.1 because that's their limit of what the margin of error can be. Now for p hat, we're just going to use 0.5 as an estimate of what p hat could be. 0.5 times 0.5 is going to give me 0.25. That's the largest thing I could possibly get in the numerator of that fraction, right? If I maximize the p hat to be 0.5, that makes 1 minus p hat also maximized to 0.5. It's making this numerator as large as possible, so it's basically like a safety net. If we guess like 0.2 as p hat with no logical explanation for why that would be a good guess, 1 minus p hat would be 0.8, and then we'd end up with 0.16 in the numerator, but there was no reason to pick 0.2 as p hat. So just to be safe, we pick 0.5. So if you have a reason to suspect that p hat is a certain percent or proportion, go ahead and use that, but if you have no idea, just use 0.5. The point of this is to estimate what n should be, so we're just going to use a safety net and say, let's just say exactly half of the people who take this survey are going to answer yes, and exactly half are going to say no. From here, it's an algebra problem, so why don't you pause the video and try it on your own. So once again, I divide both sides by 1.96, square both sides, and then I do a little bit of multiplying and dividing to get n by itself, and I get 96.04. And once again, I'm going to round that up and say we should have at least 97 students in our sample. So the key here is to remember that if you don't have a reasonable estimate of what p hat is going to be, always use 0.5. Don't be tricked into thinking there's not enough information in the problem. Just use 0.5 for p-hat.